Hi everybody, these are the chapter 3.5 notes for today. What we want to do is find the coordinates of P, point P, along the directed line segment. So a directed line segment, it's a line segment that it has a specific direction. So what that means is A to B, or directed line segment AB, we start at A and we move towards B. We always want to start with the letter that it tells us and then move towards, so start with A and move towards B. But we want to create a point P along the directed line segment so that the ratio, so when we put P on this line, it has a ratio from AP to PB of 3 to 2. So 3 to 2 ratio. So essentially, guys, we need to go up 3 to 2, or up 3/5 of the way. Now to find that ratio, we're going to start with finding this 3 to 2 ratio. So to find our ratio, we take our values, we take the 3 and the 2, and we add them together to get 5. Now we want our ratio, we want our fraction, we want it 3 to 2. So we want it 3/5 of the way. So to create that fraction, add them together, and then use that 3 as our numerator. So we're creating a fraction of 3/5. Now, essentially what we want to do, you guys, is we want to go up and over a certain amount. So when we go up and over, that's like a slope. We want to figure out how much do we need to rise and how much we need to run in order to get that point P 3/5 of the way. So what we're going to do when we hear rise over run, we're basically essentially going to take the slope. Now, this one, counting our slope out, 1, 2, 3, 4, 5, 6, our rise is going to be 6, and our run is going to be positive 1, 2, 3. Now, we're not going to simplify this. We're not going to reduce our fraction like we typically do. But what we're going to start with, think of like an XY coordinate. We need to find a coordinate for point P. So we're going to start with our X coordinate, which would essentially be the run. So we're going to start with our run. Now, again, we're not going to simplify it, but our run was 3. So we need to find our ratio 3 to 2. We need to find 3/5 of this run because we want to move over 3/5 of that way. So again, put your fraction over 1. 3 over 1 times 3 over 5, we're going to get 9/5. And if I were to do this in my calculator, 9 divided by 5, I'm going to get 1.8. So essentially, guys, I need to start at 3, where my X coordinate is, and I need to move over 1.8. So essentially, to find my X coordinate for point P, I'm going to start where A is, because that's my starting point. My X for A is 3, and I'm going to add on to that 1.8, because 1.8 is 3/5 of that direction. So I'm going to go over from my A value, 1.8, so about right here. Okay, comma, now we're going to do this for my rise. We're going to do this for my y's. So I just took care of my x's. Now I'm going to take care of my y's. Now remember, y's are rise. Y's are rise. My rise is 6. And again, I want 3/5 of 6. So I'm going to put that 6 over 1. And I'm going to get 18/5. 18 divided by 5 is going to be 3.6. So essentially, you guys, from that 2, where my y is, I need to go up 1, 2, 3.6. So essentially from my y, which is 2, from my starting point, which is 2, I'm going to add on to that 3.6. So my point P is going to be at 3 plus 1.8, which is going to be 4.8. Comma, 2 plus 3.6, 5.6. So if we look, starting from A, or starting from 0, 0, we go to 4.8. And then we go up to 5.6. So 5.6. And about right here is point P. So we're going to put that point P on the line. And that's our point P. So the coordinate of point P is 4.8, 5.6. Okay, so we're going to do this again. Find the coordinates of point P along the directed line of segment AB so that AP to PB is the given ratio. The given ratio is 4 to 1. So finding our ratio, 4 plus 1 is 5. We want it 4 to 1, so we want it 4/5. All right, so we're going A to B. Now, order matters on this because what we don't have is a graph, so I can't just count my rise over run. I need to find my actual slope. My actual slope, y2, so slope formula, back from algebra, y2 minus y1 divided by x2 minus x1. Now, for these, you guys, order does matter. Order is really, really important here. So remember, you guys, we started A and we moved to B. So B has to be my x2, y2. A has to be my x1, y1, or things are going to go a little funky. So we're going to find our slope, find our rise over run. So y2 is 4 minus y1, which is, not 1, but 3, divided by x2, which is 8, minus x1, which is 1. And so we're going to get a rise of 1 and a run of 7. Okay, so now our job, we're going to start with our run because that's our x coordinate. So I'm going to even put that x next to it, which is our run, which we got as 7. Remember, run is our x's, 7. And we want 4/5 of 7. So 28/5. Taking 28, dividing by 5. And we get 5.6. So point P, again, starting at A has an x of 1. So we're going to take 1 and we're going to add to it this 5.6 that we now need to move over. Then we're going to do our y calculation. So our y calculation here, which is going to be our rise was 1. And we want to go 4/5 of that. So we end up with 1 times 4/5, which is 4/5. 4 divided by 5, 0.8. And decimals are going to help us out a lot here. Now our rises are y's. So again, we started at A, so we need to use the y from our A, which is 3. And to that, we're going to add on 0.8. So our coordinate for point P is going to be 6.6, comma, 3.8. All right, now, kind of moving back a little bit towards Algebra 1 again. So this should be a little bit of review, but we're going to keep going through it again. Point slope form. So these two things I would highly recommend memorizing. You won't be giving them for the test, so I would memorize them. Point slope form is y minus y1 equals m times x minus x1. Now, y and x, those are going to stay variables. Those are going to stay y's and x's. But your y1 and your x1, that is going to be the given point. Whatever point you're given, you're going to plug it into x1, y1. Now, we use point slope form to get it into slope intercept, which is what we're used to, y equals mx plus b. Now, there's going to be a couple different ways to do these problems, but I'm going to show you the way that I teach it. If you've learned this a different way, that's okay as well. So slopes of parallel lines. So in a coordinate plane, two distinct non-vertical lines are parallel if and only if they have the same slope. So we need to remember, you guys, the biggest thing is lines are parallel if they have equal or same slopes. Okay, so when we're creating these lines, we need to remember that they have the same slopes. Perpendicular lines, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. So what that means, you guys, perpendicular lines have opposite. When we say opposite, we mean plus and minus, so opposite signs, and reciprocal slopes. So they're opposite, one's a plus, one's a minus. And then reciprocal is, instead of 3/5, our reciprocal would be 5/3. So if we had 1, the reciprocal of 1 is still 1. You flip the bottom and the top. If I have -2, the reciprocal is going to be -1/2, because remember there's that 1 right there. So perpendicular slopes are going to be opposite and reciprocal. So if one is positive 3/5, the other one's going to be negative 5/3. If one is positive 1, the other one's going to be -1. If one is -2, the other one's going to be positive 1/2. Opposite signs, reciprocal slopes. All right, so we're going to determine which of these lines are parallel and which are perpendicular. So we're going to start out by just starting to find their slopes. So we're going to start by finding the slope of the blue line. So slope of line A. So our slope of A, we started here, move to here, is a rise of 1, run 1, 2, 3. So it has a slope of 1/3. Our slope for B, starting here, moving here, has a rise of 1, a run of 2. So rise 1, run 2, rise over run, 1/2. Slope C, starting here, moving here, has a rise of 1, run of 2. So again, 1/2. And line D, slope D, is right here, rise 1, 2, run -1. So rise 2, run -1, or -2. Okay, so if we look, slope of B and C are the same. So lines B and C are parallel. Now if you look at line D has an opposite sign from B and C. B is positive, C is positive, D is negative. And the reciprocals, -2 or 2 is the reciprocal of 1/2. So D, line D, is perpendicular to line C, and D is also perpendicular to line B. So for example 4, again, we're going to calculate our slope starting with A, B, C, and D. So A has a slope of 1, 2, 3, 4, rise 4, run +2. So A has a slope of 2. B has a rise 1, 2, 3, 4, run 1, 2, again 4/2, so 2. C has a slope +1, 2, 3, +1, so 3/1, or 3. And line D has a slope of rise 1, run -1, 2, 3, or -1/3. So if we look here, A and B have the same slopes. So A is parallel to B. And then line C and D, one is negative, one is positive. They're reciprocals of each other. So C is perpendicular to line D. All right, continuing on. All right, continuing on to example 5, we're going to write an equation that passes through the point -1, 1. That is parallel to this line right here. So back up here, you guys, we learned two equations, y minus y1 equals m times x minus x1, and y equals mx plus b. So what I want you to do is we're going to put our equation eventually into slope-intercept form. So essentially into y equals mx plus b. Now I'm going to show you how I would do this, but there's other ways to do this too, so we can talk about that on Wednesday when I return. But we're going to first start by putting into our point slope. Y minus y1 equals m times x minus x1. Now if you guys remember back to the beginning of the notes, I told you that x1, y1, that's the point that you're given. So we're looking to write an equation that passes through the point -1, 1. That's going to be your x1, y1. So -1, 1 is going to be your x1, y1. Our job now is we just need a slope. Well, if you look back in the stem of the problem, it says we need to write an equation that's parallel to this line. So if we look at y equals 2x minus 3, the slope here, m, remember m is our slope here is 2. Now parallel lines have the same slope. So our new slope, right down here, needs to be parallel or needs to be the same as our old slope. So if our old slope was 2, our new slope also needs to be 2. So now we have enough information. We have a point, negative 1, 1, and we have a slope. So we're going to write it into our point slope form. We keep y the way it is, minus y1, which is going to be 1, equals our slope, which is 2, parentheses, x minus x1, which is going to be negative 1. And then all we do is do our algebra to get it into the form y equals mx plus b. So y minus 1 equals 2, and negative x plus 1. Distribute that 2. Y minus 1 equals 2x plus 2. Add 1 to both sides. So y equals 2x plus 3. So now we have the equation y equals 2x plus 3, which is in slope-intercept form. That's parallel to the given line. So again, y equals 2x plus 3, our slope is 2. Down here, y equals 2x plus 3, our slope is still 2. These lines are parallel, but now it goes to the point negative 1, 1. Looking at example 6, we're going to write an equation of a line that passes through a point 2, 3. So again, x1, y1. This time, we want it to be perpendicular to this equation right here. Well, our job is to start by finding the slope. So we have the equation 2x plus y equals 2. But in order to find our slope, we need to put this in a slope-intercept form. So I need to essentially get y by itself. I'm going to subtract 2x on both sides. So y equals negative 2x plus 2. So my old slope is negative 2. But now for my new equation, I need a new slope. This time I want my equation to be perpendicular. So with perpendicular lines, our slopes are both opposite sign and reciprocal. Now, 2 is positive, so our new slope is going to need to be negative. And the reciprocal of 2 is 1/2. So the new slope that we're going to use is negative 1/2. So we have the point 2, 3, and our slope, which is going to be negative 1/2. So our job is to write an equation of the line using these two pieces of information. Well, y minus y1, so y minus 3 equals m negative 1/2 x minus x1, x minus 2. All right, now distribute this so that we can get into slope-intercept form. Y minus 3 equals negative 1/2 x. Negative 1/2 times negative 2 is positive 1. Add 3 to both sides. Y equals negative 1/2 x plus 4. And that right there is my equation. All right, if you guys have any questions, please let me know. We will come back to examples 7 through 10 on Wednesday. All right, guys, have a good day.